Hello, everyone, and welcome to this Clean Energy Ministerial side event. The topic is nuclear heat for decarbonization of hard-to-abate sectors. My name is Ann Chada. I am the Chief Executive of Top Tier Impact Strategies, and I have the honor to be your moderator for this event and this incredible session we are holding today. I would like to introduce Seth Grae. Seth is the President and CEO of the Lightbridge Corporation. Seth, the floor is yours. Thank you.
Thank you, Anj. And thank you to Nice Future and Terra Praxis for inviting me. When you look at some news articles, you may get the impression that we are making serious progress on decarbonizing our economy. We have some progress in the electricity sector, reducing emissions in some countries as we have switched from coal plants to natural gas plants, reduced economic activity from the COVID-19 pandemic has also tamped down emissions. But these effects are like being on a sugar high, from which we are going to come down hard as we move on from electricity to sectors that are more difficult to decarbonize. For some sectors, such as aviation, shipping, and transportation, we have done relatively little to reduce emissions. The same is true for cement and steel production. Nearly all of the power to drive these sectors comes from fossil fuels. As we look to sources to replace these fossil fuels, nuclear energy has many advantages beyond preventing carbon emissions. Nuclear energy runs 24/7 and has immense energy density and a small environmental footprint. In short, if we are going to succeed in decarbonizing across all sectors of our economy, nuclear must be a major part of the solution. For some applications, we can use nuclear energy as a straight replacement for burning fossil fuels. For others, we can employ more complex solutions. For example, we can use high temperature heat produced by reactors to separate hydrogen from oxygen, producing pure hydrogen for zero carbon liquid fuels and fuel cells in these difficult to decarbonize sectors. High temperature steam electrolysis is more efficient than room temperature electrolysis. This process can be done at low cost because the electrolysis reaction is more efficient at higher temperatures, which can economically be produced by reactors. As the cost of producing hydrogen falls, as advanced nuclear reactors and fuels are developed, hydrogen can also be used to produce industrial heat. This is very important because industrial heat makes up 2/3 of industrial energy demand and almost 1/5 of global energy consumption. It also constitutes most of the direct industrial CO2 emitted each year, as most industrial heat originates from fossil fuel combustion. Industries use heat for a wide variety of applications, including washing, sterilizing, cooking, drying, preheating of boiler feed water, and much more. In order to produce clean energy, nuclear is scalable, so it can expand to the enormous size of the challenge we face. The scale of this problem is truly enormous, and the clock is running. We have less than 30 years until 2050. That is less time than the duration of a standard mortgage on a house in the United States. So the time to start is now. Thank you. I look forward to the discussion.
Seth, thank you very much. I believe it's been a great round of statements to begin with, and there are some questions I may ask, beginning with a quick statement that, we need 100 times scale up in less than 30 years to meet this challenge. We need a very large market to achieve the scale, but we also need to create purchasing mechanisms where every single ammonia project, for example, can achieve the target cost or below, which is contracted to do so. Do we see the evidence of any of these coming along at this stage? So I open the floor, so please, anybody would like to pick that up.
I think to date, the climate and energy discourse has been, understandably largely focused on the electricity sector. And that's important because there's a lot of opportunities there to decarbonize and also to expand electrification into other sectors to support that decarbonization. But as we've heard today, there are a lot of, hard to abate, unsolved parts of the challenge that do need to be addressed in other ways. And, that's, I think, now what's becoming more of a priority. We're looking for new production options. Go to Rita and Seth.
To start answering your question, what are we seeing today? The Department of Energy in the United States is funding 3 pilot projects to generate hydrogen from existing nuclear power plants via low temperature electrolysis at first, and then moving to high temperature electrolysis. And I think this is it's a step in the right direction to demonstrate using nuclear power plants for non-electric applications, as well as creating additional revenue streams for existing power plants. And certainly we can use these examples to build off and deploy new fuel concepts, for example, use the technology to desalinate water as well. But I think seeing the demonstration at these plants in these pilot projects is really key, and it's very exciting at the moment.
Thank you. Seth, would you like to jump in?
I felt for many years that the world would not meet climate goals, that we will find out what it's like to live in a world with average temperatures increased more than 2 degrees C. The hard to decarbonize sectors such as aviation and shipping are just too hard to decarbonize cheaply enough at global scale. When I read the Missing Link report, I thought for the first time they had found an approach that could work. And I very much want to commend in particular Rita's work at DOE for really truly making a difference and setting the stage for bringing forward technologies that really might work in time. I really haven't seen an effort like this before. So I want to thank Kirsty and her colleagues, particularly Eric Ingersoll, and in particular Rita, who on the ground have really brought things forward that bring hope.
Thank you very much. Kirsty, would you like to respond to that?
Oh, I'm just feeling bashful. That's really kind of you, Seth. And I agree with you about Rita's incredible efforts. But Tanaka-san, I think you're ready.
Yeah, well, thank you very much. I mean, and the question is that, is it really happening? Well, I think Japan has started talking about hydrogen some time ago, but we are not really moving ahead quickly enough about this hydrogen fuel cell vehicle refueling station deployment. And in fact, China has overtook us, and now the Europe overtook, and moving much faster by huge investment. So about hydrogen, the thing is, when Japan is really starting talking about hydrogen, nobody dances with us. But with China starting dancing, everybody starts dancing together. So Europe is moving ahead because of abundant renewables should be utilized by storage of hydrogen and using it in gas, etc. So this hydrogen strategy is more or less, of course, sustainable strategy, but national security or energy security policy for China to get more renewables usable is reducing oil and gas dependency to the Middle East and from Russia or from the United States. So Europe, the same thing. Energy security, if we think about energy security, using hydrogen as a storage is a really meaningful way. So renewable is abundant everywhere. Chile will be a very important security, let's say, provider in the future if the trading of ammonia or blue hydrogen is taking place. Japan is trying to, replace liquid natural gas to liquid hydrogen or liquid ammonia or chemical hydrate, and help Asian developing countries to decarbonize hard-to-abate sectors like coal power, etc. Mixing hydrogen with coal is a very easy way to reduce carbon dioxide in these countries. So Japanese idea is, okay, let's make a big supply chain of hydrogen around the world of connecting players together and try to reduce, because Japanese reduction is not a big deal, but if we engage emerging Asia or growing Asia, the impact is much, much more significant.
Thank you. Dr. Platt, yeah, thank you.
Yes, may I just put your attention in a project that we're doing down in Patagonia. We're putting the Patagonia wind into synthetic fuels. The project is of course, it's now starting. It will start production in March next year. It's called HIF, Highly Innovative Fuels. And what we will do is pack the wind into a bottle and making green hydrogen, methanol, and gasoline. And that is on a big scale. We have had even help from the German government. We do have a fund. So pay attention to that, because it's important that this will be on the gigawatt scale. It's very interesting because, of course, there we have wind with 70% plant factor, which is crazy. Because we have very high winds, 11 meters per second, and very constant all around the year. So this will be a decarbonizing of a lot. We calculate in 4 or 5 years, we will be can have zero emission fuel for all Chile, or 14% of Germany's fuel consumption. So it's quite a lot. So we will continue in that effort to scale up these technologies on a scale which worldwide hasn't been done. And we are very proud of this kind of project that I hope you can come and visit us.
Thank you. Carlos, I think you wanted to come in.
Yeah, I just want to agree with the sentiments that I'm hopeful also of this new opportunity that is before us to solve this very important problem. But I think we still need to address specifically about the nuclear technology and nuclear industry. It's a chicken and egg situation too. We need to develop the markets, right? I mean, there's a great potential for hydrogen and ammonia markets, but that will require different business models to deploy nuclear as well to meet that demand. So I think how to address the challenges the nuclear industry faces today, it's still a lot of work to be done in a short amount of time, and we can get into that if you like.
Thank you. I think, as you said, you talked about the markets itself, so I will ask Fukuzumi-san, working in the private sector, I mean, how would we scale up these markets?
So I think, we are somehow living in a democratic world, and the meaning that we somehow need to work on that some economic principle or that the market competition. So we think that the real market takeoff may start with the low cost, application, meaning that the Armin-san's, country Chile has that, the rich renewable resources. So the one project where we invested is the South Australia, also the similar, situation. So the renewable, generation electricity is very low, cost is very low, like less than Australian $30 per megawatt hour, which makes the less than $3 per kg hydrogen. And on paper, we are working on the somehow $600 or $700 dollars per ton ammonia right now. Our target is, of course, at the $400. but the choosing that some of the possible promising location, and then they do the actual, feasibility study as well as the field activity, which we are currently doing, involve ourselves and also deploying that hydrogen compressors and storage, without having the real demonstration that we really cannot know that whether that price level is nearly coming to the real. And then maybe with the slight subsidies, we can maybe achieve that, the actual commercial, scale, the production. But our approach is starting from the actual practical case, which may be the low cost renewable generation first, and then takes off that the market, green ammonia, green hydrogen ammonia, then probably working on more economical way of producing the hydrogen by centralized, more dense energy, methodology, which will be nuclear anyway. But to overcome that hurdle of that new nuclear, the station, that we have to somehow show that the actual proof of concept by realizing that actual project, first of all, with the renewable energy. That's our strategy currently right now.
Thank you very much, Fukutsumi-san. Nagatani-san, I'd like to bring you into this. One side is the markets, investments, and the other side is the regulation. So how do we make sure that regulation is also catching up and evolving fast to get to this goal we need to get to very quickly?
Thank you very much. I think that's a very good question. So when it comes to deploying hydrogen to the market, especially hydrogen produced from nuclear, we think that addressing regulatory issues is very important. So we think that we need to first of all excavate the condition for producing hydrogen in next to nuclear facility. So that's the first one step, and that also needs R&D as well when it comes to producing hydrogen next to nuclear facility. So we would like to establish necessary technologies by 2030 to produce hydrogen in the vicinity of a nuclear facility. And then we can really scale the nuclear hydrogen, especially utilizing HCGR and so on.
Thank you. Kirsty, I believe you would like to jump into that.
Yeah, this is great because, really to meet these very ambitious timescales and the scale of the challenge, we need to move forward on all fronts. And what we're hearing from Chile, from Japan, from the US, from the UK, that, we're seeing like real progress moving forward on all fronts. And in particular, it's really important to remember that there will be a lot of, transfer of knowledge and technology development across all of these different technologies. So all of this innovation that we're seeing, is the rising tide that lifts all the boats ultimately. I thought that Carlos made a really good point about, the need for a sort of paradigm shift in the nuclear industry. We've seen really successful cost reduction and increased rates of deployment in wind and solar, and there's really an opportunity for us to learn from that success and apply much of that learning, not only in terms of technology development and improved efficiency and performance of the technology, but also access to finance and procurement and policy interventions and so on that supports that innovation, commercialization, and ultimately large-scale deployment. The really interesting thing, just finally to say about the opportunity for high temperature heat sources, nuclear technologies to produce commodities to make liquid fuels like ammonia or synthetic hydrocarbons, is it's really different from the utilities-based model that we've traditionally seen in the nuclear sector. It allows you, first of all, a lot more flexibility in terms of where you site your facilities. If you have a gigafactory refinery scale facility, for example, you can locate that where it's appropriate, where it's convenient for you to do so, rather than being tied to the electricity sector and the transmission requirements. And it also allows you to deliver a scale for your product, for your project, because you're producing commodities that can be stored and transported and exported to global markets. So that's a really different business proposition for the sector and enables real investment to be made in the manufacturing facilities to really deliver those very low costs and that very large scale. So I think that there really is an opportunity here to achieve that paradigm shift that Carlos is very, correctly identifying as being needed.
Kirsten, thank you. I think we've got probably 3 minutes left, but I would like to bring Rita into this conversation around the role of financial markets. So we talked about investments and we need to scale up. The one side is regulation, the other side is the financial side. Obviously, governments can't solve everything themselves. So what role do you see of the financial sector and how that can be expedited?
I think we really need to be paying attention to the private investment financial side of things. Angel investors, philanthropic interests. There's a lot of potential funding out there, and it's looking for clean energy investments. And that's exactly what we're talking about. Not only clean energy, but clean energy taking the place of fossil. And so I think us as an industry actively engaging with those types of investors, potential investors, is very important. And then also certainly, continuing to work with the large global entities. In the United States, Development Finance Corporation recently reversed its posture on deploying new nuclear, so that's really good news. World Bank is still not there yet, but I think given the crisis that we do have globally with climate change, I am optimistic that posture might change. But certainly, and I think we go back to Carlos's point as well, we need to do a better job of marketing our technology and talking about it as a tool to help with this crisis at the moment.
Carlos, would you like to add anything before we end?
Yeah, I think we hit all the high marks. I think there's a great potential for nuclear again to play an important role in the decarbonization of these very hard to abate sectors in transportation and shipping. So I think the challenge is before us, and we just need to work together to figure out a solution, because the plan is not waiting for us. So we need to act on it.
Thank you very much. On that note, I would like to end our Grae session. So I'd like to thank you all for participating here. It's been a true pleasure sharing this side event with yourself. I would like to extend a special thanks to our organizers, Terra Praxis, Third Way, ClearPath, and Nice Future Initiative for gathering such a great and distinguished panel. I would like to wish you a nice day and look forward to an excellent series of clean energy ministerial events this week. Thank you very much.